This video is all about displaying data. So lots of stuff that you've seen in the past, bar graphs, histogram, box and whiskers plot, pie charts, all of that stuff. Just different types of ways that you can display your data. So our learning target is I can display and interpret data. So here's just some basic information. Bar graphs and histograms. Bar graphs is a graphical display of data using columns of different heights. Histograms are similar to bar graphs, but the columns are usually next to each other and they show the frequency of quantitative variables. So the difference between a bar graph and a histogram: in a bar graph, each column represents a group defined by a categorical variable. So labels on the x-axis are categorical. In a histogram, each column represents a group defined by a continuous quantitative variable, so a number. Labels on the x-axis are quantitative. So in a bar graph, you're going to have actual words, and in a histogram, you're going to have numbers. That's the difference. Okay, so let's look at this. On the left is a bar graph. So notice that for your categories, you have words, and in the histogram, your categories are actual numbers. So that's the difference. Okay. You can read through this. So if I'm looking at the histogram, the number of colleges that are between 0 and 5,000, I just count them, are 1. The number of colleges with tuition between 5,001 to 15,000 are 6. The next one, 3. The next one, 4. So it's the same, except bar graphs are for word categories, histograms are for number categories. Alright. Okay. So very quickly, I'm just going to make a bar graph and a histogram for both of these. You can try it as well if you want to, but you can look at what I'm talking about in just a minute. Okay, so you can see my really rough sketches. Notice the bar graph, the bars don't touch. The histogram, they do. Notice the x-axis is your categories. So on the bar graph, you got the different types of books. On the histogram, you got the different college tuition ranges. And on the y-axis, you have the frequency that they occur. So that's just a little review for you. Okay, so now let's look at this one. So this chart looks a little confusing. There's a lot going on. So this is the percent of people saying there are too many women, too few women, or about the right number of women in high political offices in the country today. And you can see that they're in different categories. So they're looking at the number of men who answer, the number of women, Republican or lean Republican, and Democrat, lean Democrat. So it's all very spaced out. So what it's asking you to do in the problem is make a bar graph for the percent of men and the percent of women, saying there are about the right number of women. So that's right here. And it's asking you to do a bar graph of men and women saying that. So I'm going to make a bar graph using just that data. You can try along with me and see if we get the same thing. We're going to do that in 1, 2, 3. So something like this. So women and men would be on the x-axis, because remember our bar graph is categories. They're going to be words on the x-axis. And then on the y-axis is how frequently it occurs. Alright, so the next part says make a pie chart of all respondents. So when I talk about all respondents, I'm looking at the different ones. So the ones who said there are too many, the ones who said there are too few women, and then the ones that said they're about right. So I'm going to use those 3 statistics to make a pie chart now. You can try it as well, and try it in 1, 2, 3. First thing I'm going to do is I'm going to redo the colors a little bit, just to keep it more on track. So here's what a pie chart looked like. 34% of all people said they were about the right number, 6% said there were too many, and then 59% said too few. So your pie chart should be in line and proportional with those categories. Alright. So let's do some analyzing. So is a pie chart appropriate for this data? And really, I'm just looking for your thoughts on this. So anything that you put down and makes sense mathematically and you actually put some thought into it, I'm going to count. And then the next thing I want you to do is think of an example where a pie chart would not be a good way to represent a set of data. So I'm just looking for your thought process on this, seeing if you can actually think, make a coherent thought, Just think about something. Alright, and when you get that done, we're going to look at finding marginal distributions. So data for analysis in categorical variables can be displayed in contingency tables. So that's what you see below. The table shows the number of subjects observed at all combinations of possible outcomes for two variables. So it's just going to be very specific. So what you're looking at is you have a sample size down here of 2,982, and out of that, it's broken up into gender, females or males. It's looking at party identification, so either you picked Democrat, Independent, or Republican, and then it's looking at your totals. So the row totals and the column totals are called marginal distributions. Often the frequency is converted to percentages to show the relationship between variables. Okay. So here's what we're going to do. We're going to calculate the marginal distribution for being female and Democrat. Here's how you do that. So you look at the chart. I look at how many females are Democrats. I get 574. And then you're going to divide it by the total. And remember, the total was 2,982. So when I put that in my calculator, I get 0.192. And if I convert that to percentage, I'm going to move the decimal place over twice. So I get 19.2%. So that is the marginal distribution for being female and Democrat. So now what I want you to try is I want you to try number 1. Calculate the marginal distribution for being independent and male. Try that in 1, 2, 3. Okay. So independent and male is right here, 560. I'm going to divide that by the total. I put that in my calculator, I get 0.188. If I convert that to percentage, I get 18.8%. I forgot the 8. Okay. Alright, so if you did that, that's good. Alright, so the second one is a little more advanced. So we're going to calculate the marginal distribution for being female and independent, or you can be Republican. So let me do that in some different colors. So you can be female and independent, or you could just be a Republican. So if you want to try it, you can do it in 1, 2, 3. Okay, so for being female and independent, there are 585 people who are female and independent. Or it says you could be Republican. So here are my female Republicans. And so sometimes it's a little hard to see what they're doing, but they're phrasing it as being female and independent or being female and Republicans. That's why I'm only getting the female Republicans. So I'm going to add those two together, and then I'm going to divide by the total. Alright, so when I put this in my calculator, I get 0.305. And if I change that to a percentage, 30.5% are female and independent or female and Republican. Okay. Now let's try this one. So we can use the same data to make segmented bar graphs. So a segmented bar graph is going to be a bar graph, but it's going to be color-coded. So the bars are going to be different colors because they're going to represent different types of data. So I'll show you what I'm talking about. First off, if you're given like a table like this, you can do just simple math. Like I could add females and males together to get the total. I could do 1,145 minus 585 to get 560. I can do 780 minus 456 to get 324. And then, so just simple math can get me anything that's not there. So sometimes they don't give you the entire chart, but there's enough common sense you can use. There's enough material there to actually do this. So we completed the information. So now we're going to draw a segmented bar graph that shows the distribution of party identification by gender. Okay. So here's what we're doing. I'm trying to figure out the different parties, what their gender looks like. So there's two genders we're talking about. We're looking at females and males. And we're going to do one bar, but we're going to have it color-coded into the different party identifications. So something that makes it easier, if you'll go ahead and find the marginal distributions for each. So what I'm doing is I'm using orange to represent the Democrats, purple is going to represent independent, and Republicans are going to be red. So if I want to find Democrats that are females, I'm going to do this divided by the total. So, and not the total like the 2,982, but I'm going to do it by the total number of females because that's what I'm looking at. So these are the fractions that I'm going to be finding. And then when I do these other ones, I'm going to divide them by the total number of males. And I'm going to get a decimal, and then I'm going to go ahead and convert those to percentages. So there are my percentages. And both of these are going to add up to give me 100%. And now that I'm looking at them, I noticed that this one kind of doesn't. So let me change this to 38. I'm just going to fudge it a little. Okay. There we go. Now they add up to 100%. So now you would use your colors. So like 39% of females is going to be orange. And then about 32% of females is going to be, of males is going to be orange. So remember, orange denotes Democrats. So then you would have like a little key over here. Orange for Democrat. And then we got independent. And we got Republican. So this is what a segmented bar graph looks like. So there's still going to be bars, but they're going to be different colors to represent like different categories within the big categories. A little weird. So females, males. Remember, these are my independents. And then I got my females and males that are Republicans. So something like that. And that's a rough sketch. That's not actually like plotting them on an axis or anything like that. Okay, so some other things you may have done are called dot plots. So dot plots are really easy. A dot plot is a simple way to graphically show the frequency of data within categories or groups. Dot plots are not good for large data sets because that's a lot of dots you gotta plot. So here's an example. Here are some quiz scores. So if you label the x-axis, you would label it quiz scores because that's what it is. And then you would just plot a dot for everywhere, like you have some data. So the first one's 12, so I put a dot at 12. Then I see 21, put a dot at 21. I see 18, I put a dot at 18. 19, 20, 16, 17. And then with dot plots, you just go up anytime you have extra data. So you can pause the video and you can try it, and then we'll answer some questions. So do that in 1, 2, 3. Okay, so it should look something like this. So the purpose of a graph is to help us identify the data. What do you see? What's the overall pattern? And what data doesn't fit? Then those are called outliers. So what we're going to do is we're just going to answer these questions. So if you were to describe the shape, you could say, so most data is from 17 to 21. You could put the most frequent was 18. You could say that there are a few scores on the left tally of data showing a skewed distribution, something like that. So the spread, you just talk about like the range of values. So the range of scores was from 9 to 21. So that's what spread means. Sometimes they ask about center. So can calculate the median mathematically or look at where the center seems to be. So you can look at it. I would say the median is at 18. Alright, and then outliers. So outliers are data points that are distant from other data points. So I would say 9 is an outlier because it's really far from all the other data. Okay, so that's the kind of things they could ask you about dot plots. So now I want you to try this one. Make a dot plot and then see if you can analyze it. Try it in 1, 2, 3. Okay, so you can look at the dot plot. So when I described the shape, I said the data is skewed left because most of the data is towards the left. The majority of students have between 0 and 2 siblings. The spread is from 0 to 8 siblings. The median is 1.5, or you could have said between 1 and 2, and the outlier is 8. So very simple, just plotting data, looking at it, answering some questions. Alright, so let's look at some box plots. Alright, so box plots can also be called box and whisker. That's probably what you've known them as. And they display 5 key numbers. So they look at the minimum, the maximum, the median, the first quartile, and the third quartile. So in order to do this, the first thing you do is you're going to put the numbers in order from least to greatest. So I'm going to pause the video and do that. You can do it along with me. Alright, the next thing you want to do is you want to divide the numbers into 4 sections or quartiles. So like right here, here, here. So they're even numbers, like there's 3 numbers in each quartile. And then, so the median number would be right here. That's going to be my Q2. That's also called your median. Alright. Your Q1 is going to be in the middle of that, and Q3 would be over here. So when you do this, you're going to find the minimum maximum. So the minimum is 2.2. and the max is 3.6. We said that Q1 is between 2.7 and 2.8, so I'm going to call that 2.75. Q3 would be between 3.1 and 3.3, so 3.2. Alright. The interquartile range, so that's when you do Q3 minus Q1. So I get 0.45. Right, and then we're going to use that to create a box and whiskers plot. And so if you don't remember, here's how you do it. Did not mean to write that. Okay, so your Q1 you're going to plot. It is at 2.75, so let's say about right here. And then you're going to plot your Q2, and then your Q3, which was 3.2, and that's your box. So Q1 is always here, Q2 is here, and Q3. And then your whiskers are your min, so down here, and your max. And your max was at 3.6. So that's just a little review on how to do box and whiskers. So you're looking at 5 data points, and that's how you find them. Okay. Alright, so when we're interpreting data points, a box plot can provide key information about the distribution of data. So the median is indicated by the vertical line running down the box, the middle of the box, wherever it's at. The range is the distribution of data. And then when you talk about interquartile range, that's when you do that Q3 minus Q1. That shows where the data is concentrating. So if it looks like this, we would say skewed right. So if more data is to the right of Q2, it's called skew right. When Q2 is directly in the middle of the box, that's called symmetrical. And when Q2 is more to the right side, we would say skewed left, because there's more data to the left of Q2. Okay, so here's what I want you to do. I want you to construct a box plot for this. So you're going to have to find the minimum, maximum, the median, the range, the interquartile range. Then we're going to find the outliers, and then we're going to describe the distribution. So either skewed left, symmetrical, or skewed right. So what I want you to do right now is you can go back and look at that first problem we did, but I want you to create the box plot. And try that in 1, 2, 3. Alright. So this is the data you should have got, unless I did it wrong. And then I just sketched a little graph. I didn't actually do it to scale. I just kind of, like instead of doing numbers to 79 to 111, I just did a little sketch. So when we find the outliers, okay, you're going to do the number you got for Q1, and then you're going to subtract by 1.5, and then you times 1.5 by the IQR. So remember, the IQR was 9.5. So when I do this, for Q1, I had 84.5 minus 1.5 times the IQR. Goodness, I can't even read that. So I got 70.25. So there's nothing below 70.25. So I say there were no outliers in that set of data. And then you use the same thing. So Q3, I got 94. And then I'm going to subtract 1.5 times 9.5. And when I do that, I get 108.25. And there was one data point that was past 108. So I would say 111 is your only outlier. Okay, so when you describe the distribution, it's like you could call it symmetrical, but if you actually look at it, you would actually say it's going to be slightly left. So skewed slightly left. Just because Q2, that 89, is not directly in the middle of 94.5 and 94. So based on how it looks, I would be perfectly fine with you saying symmetrical, but if you look at the math, it's just slightly skewed left. So that's why I said skewed slightly left. But if you put symmetrical on a test or quiz, I would totally count it, because I did it. Alright, so here's one more to try. I want you to pause the video, and I want you to answer all of it based on the two previous problems we just did. So try this in 1, 2, 3. Okay, so hopefully you got something like this. The median was 25, the minimum 18, the maximum 30. The range was between 18 and 30. So when you organize the data, Q1 22, Q3 28, which makes the IQR 6. When you do that formula that we did on the last problem, you can go back and look at it. There were actually no outliers. And you can explain by showing me the formula. And then I said this data is not really skewed, because it is kind of dead on. If you wanted to say slightly skewed a certain way, I would accept that too. But it's not, it's not like that significant. So I just put non-skewed. Alright, so let's look at some stem and leaf plots, because I bet it's been a while since you've done these. I actually hate these, but don't tell anybody. So in a stem and leaf plot, the data is split into stem, it's the first digit, and the leaf is the remaining digits. So for example, for 32, the stem is 3 and the leaf is 2. So that's what it's showing you in the picture. So here's how you do it. Step 1, line up the data in order from least to greatest. So I'm going to pause the video. You can do it as well. 1, 2, 3. Alright, and next we're going to put that data in the stem and leaf plot. So for 0, definitely 8 and 2 would go with that. For 1 is only a 12, so a 2. For the 20s, I have 0, a 3, another 3, a 4, and a 5, and a 9. So there's your stuff. Okay, and then we're just going to do the information that you see right here. So the range, if I do the maximum, which is 32, minus the minimum, I get 25. How many entries are in the stem and leaf plot? So you just answer that. Usually you're going to use n, because n represents sample size. What's the median? It's 23. The interquartile range. Oh, trying to move the paper up, sorry. So if you look at Q1, it's actually 12. Q3 is 29. So if I do 29 minus 12, I get 17. Alright, so I want you to try it now. Pause the video, see if you can do this in 1, 2, 3. Alright, so here's what I got for this. You can message me if you're still having trouble. I think it's pretty easy. I really hate stem and leaf plots. I don't understand why you would ever use them, but whatever, we'll go back over it. Alright, here's the last thing. Oh, nope, we already did that, so we're good. Let me know if you have any trouble. Alright, I want you to try this one. It's just looking at quiz scores. So you're going to do a stem and leaf plot, you're going to do percentages, and you're going to answer. So pause the video, see if you can do this in 1, 2, 3. Alright, so here's your percentages. Remember, this was out of a score of 20. So those are their grades, and those are the stem and leaf plots. Pause the video if you need further time to look at it. Alright, and here are your answers after analyzing this stem and leaf plot. If you have any further questions, you don't understand the assignment on Haiku, anything like that, just let me know what's going on. We'll figure it out together.